Hello friends, in the last sessions we have seen the use of lambda expression, or how you can use a lambda expression in various ways, and in this session we are going to see the functional interface. What is a functional interface? So before to that, say we'll see some other example. Say I have class, take a class here, say this is test 1 in package 10. It has a main method. So when we have written here a lambda expression. So I have an interface in1 or just in, and it is having a method some void show is the method, right? Or it is taking an argument also, say it is some string type s. So this is the interface in1, and if I want to write a lambda expression for this, then I can write in1 is just this, and it has a variable, so I'll write here it is s, and this is s, right? And so I can call this function now in1.show with some string, say hello guys, right? Hello guys, and just run it. So it is printing hello guys. So it is printing hello guys. And the implementation of this show method we have given here. This is the implementation which is taking an argument. And when you are writing a lambda expression here, you no need to mention the method name, you no need to mention the modifier, or you no need to, when you are having an argument in this, even if it is a one argument, you no need to mention this parenthesis also. You can simply write like this, and type also no need to mention, right? So this we have already discussed in previous sessions with the lambda expression. Now assume this interface in1, which is having only one method show, and that show method implementation we are giving in this lambda expression, it is this one, right? Now in this interface, if I have one more method, say void again show, and it is of type int I, if I write like this, right? Now it is another method. It is possible in interface you can write multiple methods like this by changing the parameters, right? Changing the parameters, which is called as method overloading. So now in this interface I am having two abstract method, and if I implement this interface to any class, if I implement this interface to any class, say a, and implements interface, then I have to override both of this method because both is abstract. So assume I'm overriding both of this. Now this is a perfect class, it is fine. But why we are using the lambda expression? Lambda expression is to simplify this code. Instead of overriding the function or in a class, or instead of using an anonymous class, you can just write a lambda expression. But when a function or when an interface is having multiple abstract function like this, when you are writing an implementation like this, here there is no way to identify that this is an implementation of the first method or it is an implementation of the second method, right? There is no way. We are not mentioning the method name, even we are not mentioning the data types also of the arguments. It is just a implementation with the variable name, argument name, and the implementation of the function. That's it. Now here we are not telling that it is a implementation of a particular function of a particular type with argument, or if the function is, say it is another function disp, and this is also taking a string type argument string s. Now it is different, two different function, and then in this class which is implementing this, you have to actually override here a disp function, right? And the argument is taking any type. It can be string type or anything. So it is currently it is string type here, so I'm giving here string type, right? So overriding. Now in this we are telling s can be any type, okay? And which function implementation is this? So when an interface is having multiple methods, abstract methods like this, maybe with the same name or different name, or with the same parameter or different types of parameters, for that interface you cannot write a lambda expression. Okay, you cannot write a lambda expression. So if you want to write a lambda expression for any particular interface, then the interface should have only one abstract method. Only one abstract method. Okay, the interface should have only one abstract method. And the interface which is having only one abstract method, for that we can write a lambda expression. If the interface is having multiple abstract methods, then you cannot write a lambda expression for this, because it gets confused for which method you are giving the implementation. Right. So the interface for which you are going to write a lambda expression, that should contain only one abstract method. And if any interface is having only one abstract method in that, then that abstract method is called as functional interface. Now this is a functional interface, right? Same way, if I take some other interface, say interface in1, and which is having, say, void m is a function. Now this is a functional interface because it is having only one method, abstract method, right? So for this also we can write a lambda expression now. But if I am having another interface in2, which is having, say, void m1 is a function and void m2 is a function, two different functions in this, and both is abstract. Now this is not a functional interface, right? This is not a functional interface. So a functional interface is an interface where you are having only one abstract method in it. But you can have a default method or a static method also in a functional interface, that we are going to discuss in the next session. So in this session we are just discussing what is a functional interface. So a functional interface should have only one abstract method, but it can have multiple default methods or multiple static methods also, but those will have the implementation, right? So this is a functional interface. For this two is a functional interface. Now assume for these two functional interface you have already written so many implementation like this. I am writing in1 and this is in2, and some implementation I am writing. So this is, or I'll take here, it is taking an integer type argument int, and this is int I, some integer type argument it is taking. So assume I have written an implementation for this again, say I, and it should have an implementation that is it has to print the value of I, right? And I'm calling it here in2 dot show method, or it is m method, and it should give here 99 and it prints 99, right? It is printing 99. So this is a functional interface. Now interface 1 is a functional interface, and for that I have written a lambda expression here. Or assume I have a class A, and class A is having a show method, show, and the show method is taking an argument of type interface 1 in, right? And in that it calls in.m function with some value, say 99, or say it is 101, something like this. So now if I want to call this show function from the A class, then I need to pass a lambda expression as a parameter in this. So a1 new A, this is object creation, and after that a1 dot show, when I'll call, I need to pass here a lambda expression. So I'll give this is I, and the implementation of this is it is print the I value, right? This is the implementation of this, right? So you don't need this actually. So it is done. When you are calling the show function of A class, you are providing here as a lambda expression as an argument, and just run it, or you'll give here one more message, so it is show method in A class, and this is printing, say it is m method from lambda expression, and it should take a tab space, colon 1 tab space, and print the value of I, right? So this is the lambda expression I'm providing to call this show method, and on this lambda expression show method is calling the function with this value m1, right? Now if I run this, I have to get here show A, and it is to print m from lambda expression with the value of I, and I value you are supplying here, it is 1, not 1. And before that I'll draw a line here, say it is this, and run it. So this is the output. Now in1 is a functional interface because it is having only one abstract method, so in1 is a functional interface. And for this, since it is a functional interface, we are implementing at this point 1 and implementing here also, right? And the functional interface in1 is already designed by somebody and we are using it there, right? We are using in so many places like this, or some other person are also using that somewhere like this. And after some day, some person again added one more method at this point, say void display the method and this. Now this is no more functional interface, but the implementation of this functional interface, Lambda expression, already implemented in so many places, and which is going to get a compilation fail at this point, right? Because somebody by default or accidentally someone added one abstract method in this interface, and all the Lambda expression implementation for this interface is now got exceptions, right? Got breaks here, all these implementation breaks here. So what I want is, I want a guarantee that this always remains a functional interface, and if anybody tries to add any other abstract function in this interface, it should give an error here itself instead of giving the implementation error at these places. So to do that, Java 8 provides a annotation, and this annotation is functional interface. When you say here it is a functional interface annotation, it guarantees that the interface on which you are applying this functional interface is actually a functional interface, and that you can do by using this. Now when you say here it is a functional interface, this interface must contain only one abstract method. If you give any other abstract method here, then this itself is a compilation fail. So now if I remove this, then this is fine, it is a functional interface. So this functional interface annotation is a guarantee that it is actually a functional interface. And it guarantees that accidentally, if when you are designing this interface, or somebody is designing an interface and he is making it a functional interface because it is having only one abstract method, but accidentally somebody puts one more abstract method in that, then it is no more functional interface. And in that case, wherever the implementation is given as a Lambda expression for this functional interface gets an exception, right? So to avoid that expressions in implementation, or to avoid the accidental adding of any extra abstract methods in any functional interface, you can mark the interface with the annotation which is functional interface. So this annotation is actually, if you want to design a functional interface, this functional interface annotation is not required if it is having only one abstract method. But accidentally if somebody adds a new extra abstract function on that, then this will not be a functional interface, and all these places are going to get an error. To make a guarantee that it always remains as a functional interface, you can add one functional interface annotation on that interface, right? So assume this is a functional interface now because it is having only one abstract method. So you can mark it as with functional interface. So this is fine, it is okay, no problem. But this is also an interface, and if I mark here with functional interface, then it is a compilation fail at this point only because it is having two abstract method, and it is saying here it is in2 is not a functional interface, so you cannot mark this as the functional interface. This is invalid, right? So this is not okay because it is not a functional interface. So this is what is functional interface. A functional interface is an interface which is having only one abstract method, and to make a guarantee that it is a functional interface, you can use this functional interface annotation. And for a functional interface only, you can write the Lambda expressions, and the interface which is not a functional interface, for those you cannot write any Lambda expressions, right? Next, a functional interface can take some default methods. Void, say default void m is a method, and This is M. It can have multiple default methods, or it can have a static void, say some disp is a function. So functional interface can take any number of default methods or any number of static methods, but it should have only one abstract method. Then only it will be a functional interface. And the method which is abstract, for that only you are writing the lambda expressions, right? So this is functional interface. In the next session we are going to see what is the default method and what is static method in interface in Java 8. So thanks for watching my video. Please subscribe for more videos.